Let me pose this question to you guys. So let's say you've got a graph of 1 over x, which looks something like this. So not to scale, this doubles each time. So 2, 4, 8, 16, 32, and so on. How does this area, the question is, how does this area compare to this area? And then also, how does this area compare to this area? And the pattern goes on all the way to infinity. So what's the relationship? You might be tempted to say, oh, all the areas are the same, but how do you know that? And how do you know it will always work forever if you continue the pattern all the way to infinity? Well, anyway, think about it. Press pause and have a go. Okay, so to do this, work out the area for any given 2 to the power of n, because you double each time. So for any given 2 to the power of n where n is a positive integer, so for example, going back up here, this is 2 to the power of 1, this is 2 to the power of 2, this is 2 to the power of 3, this is 2 to the power of 4, and then the pattern goes on. It's really 2 to the power of something. So going back down here, so this area, so no matter which segment you look at, 2 to the power of n, well, integrate it from 2 to the power of n to 2 to the power of n plus 1. So now if you integrate this, it will then give you natural log of x. It will then give you natural log of x, and you're integrating from 2 to the power of n to 2 to the power of n plus 1. So now you can put this thing, you can now put this whole thing into here. That will then give you this, and then you take away, put this whole thing into here. That will then give you this. And then remember laws of logs. If you have something to the power of another thing, and then you take the log of that, this thing is able to come down. The log stays the same, the base stays the same. And then here you've got one thing to the power of another thing. You can drag, anytime you have a log, you can just drag the power down. So that will then give you natural log of 2. So now if you look at this, this is exactly the same as this. So you can factor out the natural log of 2. So now this is n plus 1, and this is n. So now simplify this bit. These two cancel each other out, giving you 1. And then 1 times this thing here would just be this thing here. So the area is natural log of 2. So no matter which segment you look at, the area, if you look at this one here, 2 to the power of n, this is 2 to the power of n plus 1. So the area here is actually natural log of 2. So let's just imagine 2 to the power of n is here. So this must be 2 to the power of n plus 1. So this area is also natural log of 2, meaning all the areas are the same. Okay?